Hello friends, welcome to my YouTube channel. In today's video, I will explain the topic dynamic programming general method in the subject of design and analysis of algorithms. Okay, first of all, what is the meaning of dynamic programming? Okay, it is a problem solving technique. It is a one of the problem solving technique. It is similar to divide and conquer. Okay, it is similar to divide and conquer mechanism, but it stores the sub problem solution. First of all, what is the meaning of divide and conquer rule? Divide and conquer rule means a problem is taken. Suppose a problem is there. A problem. That problem is divided into multiple sub problems, and here sub problem 1, sub problem 2, sub problem 3. Okay, here every sub problem will get the solution, and in finally all the solutions will be clubbed as the major solution. It is the technique of divide and conquer. Okay, here what is the dynamic program means? Dynamic program is similar to divide and conquer rule, but this stores the sub problem solution. Here whatever the sub problem solution, that will be stored in a memory location in dynamic programming. That is the difference between dynamic programming and divide and conquer. Okay, what is the dynamic programming? It is a sub problem solving technique. Here it is a similar to the divide and conquer rule. Here the sub problem solution will be stored in a memory location. Okay, now see what is the dynamic programming. Dynamic programming is the problem will be divided into sub problems, and each sub problem solution, these sub problem solutions are, see, these sub problem solutions are stored in memory. Solutions are stored in memory. So what is the use of storing memory? For future references. For future references, these solutions are stored. These solutions are stored. Okay, it is one of the optimization method. And next one is dynamic programming. We use the concept of recursion. In dynamic programming, we use the concept of recursion. Here, what is the meaning of recursion? A single function defining once and call it again and again. If a single function is defined once and calling again and again. For example, if you see some function, sum of a plus b. Okay, if you declare this function, here we are declared the function sum is only one time, but we can call a plus b multiple times. Okay, same like that. It is also recursion. Okay, in dynamic programming we will use the recursion concept. Okay, here we will see the algorithm. What is the algorithm for Fibonacci? The algorithm is regarding Fibonacci series. Here I am taking in fib of n, the n value. If n less than or equals to 1, then return n value. Else return the final value is fib of n minus 2 plus fib of n minus 1. Okay, this is the major logic for Fibonacci series. What is, first of all, what is meaning of Fibonacci series? For example, the Fibonacci series means 0, 1, 1, 2, 3, 5, 8, 13. Here, what is the solution here? The Fibonacci series is nothing but what? The first value and second value. If you add first value and second value, then we will get the next value. Again, the previous two values will be added, then next value we will get. Again, these two values are be added, then we will get this one. Again, if you add these two, we will get this one. Again, if you add these two, we will get 8. Okay, here what is the logic here? The logic is very simple. Fib of n. Okay, if n value is 0, then returns the 0 value. If n value equals to 1, then returns the 1 value. Other than these two, 0 and 1, then we will implement this logic. What is the logic here? Fib of n minus 2 plus n minus 1. For example, if I want to find out the fib of 2, so what is the value? Fib of 2 minus 2 plus fib of n minus 2 minus 1. So what is the value? 2 minus 2 means 0 plus fib of 2 minus 1 means 1. So what of fib of 1 value is 1. So what is the value? 1. Okay, we will see one live example for this Fibonacci series in this problem. Okay, now in dynamic programming, how it is possible. Okay, see here, I am taking a Fibonacci series example. Find out fib of 5. Find out fib of 5. What is the formula? Fib of n minus 2 plus n minus 1. This is the logic. Okay, here I am taking fib of n minus 2. So how we are splitting this problem? The problem is fib of 5. The problem has to divide into subproblems. What is the solution here? Based on this. Okay, here I am taking fib of 3. Here fib of 4. According to this logic, 5 minus 2 is 3, 5 minus 1, 4. Okay, again we are implement this. Okay, again we have to implement. How to implement? Fib of 1, and what about this one? Fib of 2. It is possible to divide? No, not is possible. Okay, and what about here? Fib of 2. Fib of 2 is possible to divide. So, if we divide this one, we will get fib of 1, sorry, fib of 0, and here fib of 1. Okay, and what about right side? Here fib of 4, and if you divide it like this, we will get fib of 2, fib of 3. Okay, listen, how we are dividing this tree? We are dividing this tree according to this formula. Okay, fib of n minus 2 plus fib of n minus 1. Okay, again fib of 2. If you are dividing this one, we will get fib of 0, here fib of 1. And what about fib of 3? If we divide fib of 3, we will get fib of 2, fib of 1. Sorry, it is 1, it is 2. And what about 1, 2? Again it is fib of 0 and fib of 1. Okay, if you do it in general method, how many steps we are getting? See, how many functions we have to call it? First fib of 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Totally, we have to call 15 times. Okay, in general method, if you are applying to find out the Fibonacci series, you have to call 15 times fifth function. Okay, in general method, in general way, I have to call 15 times fifth series. Okay, if you implement dynamic programming, the calling the same function will be reduced. Okay, in dynamic programming, see, we have to store the subproblem solutions. Okay, here initially we have to take 0, 1, 2, 3, 4. Okay, initially you have to take fib values, all the fib values are 0. Okay, then see, once the problem is divided, here what is fib of 3 value? Fib of 3 value means 2. Okay, here what of fib of 1 value is 1. Fib of 0 is 0. Fib of 1 is 1. Fib of 2 is 1. Okay, now we will check. It is the fib of value. Okay, fib of 0 equals to, what is the value you are getting here? 0. So, we are 0. Okay, next, after that, after this one, sorry, first we will come from fib of 0. Okay, next, what is the next value? Fib of 1. So, we are taking this fib of 1. What is the fib of 1 value is? Previously, the array is stored 0. So, we are replacing with 1. Fib of 1 is 1. Okay, next, what about fib of 2 value? 2 value is 1. So, it is also overriding with 1. Fib of 2 is also 1. Okay, next, what about this fib of 1? Already we stored. So, we are not considering this value. We are not considering this function. So, no need to call again fib function here. We know fib function, fib of 1 is 1. So, we are already stored in the array. So, no need to implement this function again. Okay, we are implementing fib of 0, fib of 1, fib of 2. And what about fib of 3 value is 2. So, we are overriding fib of 3 value equals to 2. Okay, and this is the left side part is completed. Okay, here how many times were called? 1, 2, 3, 4 times were called. And what about right side part? Yeah, again here right side fib of 0. It is no need to consider, no need to call. Why? Because we know fib of 0 value is 0. And fib of 1 we don't need to call. Why? Because previously we called, we know the value is 1. So it is 1. And what about fib of 0? Again we don't need to call this one 0. And fib of 2. Again here also fib of 2 we called here. So no need to call here. It is actually this value is 1. No need to call this function. And what about fib of 3? Again this fib of 3 also the value equals to 2, but we already previously called here fib of 3. So no need to this call this part. And what about, so this entire part will be not calling in second time. And what about fib of 0? Again this 0 we called previously, so it is also not calling. Fib of 1 value is 1, so it is also not calling. And fib of 2 value equals to 1, it is also not calling. And this entire part is not calling again. And what about fib of 4 value? The fib of 4 value is, we have to call. Okay, if you implement fib of 4, again this law of this formula, we will get fib of 4 value equals to 3. So this we are overriding this 0 with 3. And what about fib of 5 value? Fib of 5 value equals to 5. Okay, now check how many times we called the fib function here. Here we call the fib function is 1, 2, 3, 4, 5. Totally how many times? Totally 5, and this is the sixth time. So now if you are using dynamic programming, we are calling fib function only 6 times. Using dynamic programming, fib function is called only 6 times. Why? Because we stored these values in the array. We stored these fib values in the array. Okay, these values are stored in array. In dynamic programming, we are storing solutions of subproblems in the array. So it is easy. It is easy to comparing by comparing general other methods. Okay, what are the applications of dynamic programming? Dynamic programming contains the applications are, okay, the first one is optimal binary search tree. Second one is 0 by 1 knapsack problem. And next one is all pair shortest path. Traveling sales person. And last one is reliability design. These are the applications of dynamic program. In this chapter, if you discuss, we will discuss these all topics, then only our unit will be completed. Okay, if you like our videos, please subscribe, and if you have any doubts, please ask me in comment section. Thank you everyone.